I'm Mrs. Nelson, and thank you for coming out tonight. I know you guys have been giving up some good evenings. So today we're going to talk a little bit about probability. So probability is the matter of how likely something is to occur. And we write probability as the number of desired outcomes over our total number of outcomes. And we're going to start really simple, just start with simple probability. So simple probability is whenever you are trying to find the probability of just one event, a single event. And events can be anything like rolling a number cube, flipping a coin, drawing a name out of a hat, just anything like that. So our first example of simple probability is, what is the probability of rolling a 3 on a number cube? So first, we need to figure out what our desired outcomes are. So if we have a number cube, how many 3s are on a number cube? One. How many total sides are on a number cube? 6. So the probability of rolling a 3 would be 1 over 6. I know that seems really simple. You probably learned that in like junior high. So here's the next example. What is the probability of a coin landing on tails when it is flipped? So again, we'll look at our desired outcome. So what's our desired outcome? Yeah, 1 for 2. Good job. 1 for 2. Desired outcome is tails. And there's only one tails on a coin, and there are 2 possible outcomes. There's heads or tails. So we have a 50-50 chance of getting tails. Okay, now we're going to talk about compound probability. This is whenever you have 2 events instead of, well, 2 or more events instead of just a single event. And there are 2 main kinds of compound probability. The first we're going to talk about is OR. So this is when you're trying to find the probability of one outcome or a different outcome. So here's an example. What is the probability of rolling a 4 on a number cube or flipping a tails on a coin? So what we want to do is find the probability of each event. So what's the probability of rolling a 4 on a number cube? 1 out of 6. Because there's 1 on the number cube out of 6 total sides. What's the probability of flipping a tails? We did this just a second. 1/2. Okay, so whenever we're doing compound probability that deals with one outcome or a different one, we use addition. So we're going to add the 2 different probabilities. So 1/6 plus 1/2, that's, well, you have to find a common denominator. And then you get 4 over 6, which simplifies to 2/3. Okay, here's another OR example. You have a big bag of snacks that includes 1 package of each of the following: Twinkies, zebra cakes, oatmeal cream pies, and Pop-Tarts. You reach in the bag and randomly select a snack. What is the probability that you select Twinkies or Pop-Tarts? 1 out of 2. Good. So first you find your probability of selecting a Twinkie. So what's the probability of getting Twinkies? 1/4, because there's only 1 package of Twinkies out of 4 total different snacks. Oh, there's the whole answer. The probability of Pop-Tarts is the same, 1 over 4. So you add these together because it's OR, and whenever you see OR, that means add. And you get 2 over 4, which simplifies to 1/2. Okay, so here's the other kind of compound probability. And it's whenever you're trying to find the probability of one outcome and something else happening. And instead of addition, so OR, you use addition and you use multiplication. So what is the probability of rolling a 5 on a number cube and flipping a heads on a coin? So we need to find the probability of each event. So what's the probability of rolling a 5? 1/6. 1 out of 6. What's the probability of flipping a heads? 1/2. So the probability of doing both, what would it be? multiply the two probabilities together. So that means it would take you 12 times to roll a 5 and flip the heads on a coin. If you were doing both, it would take you 12 times to do it, theoretically. I mean, if you actually did it, it might turn out differently. But this is just logically, that's how many times it would take you. Here's another example. So, I have a deck of cards. I'm not going to do anything really fun with the cards, so don't get too excited. But what is the probability of drawing a 4 from this deck of cards and rolling a 6 on a number cube? So first we need to look at drawing a 4. How many 4s are in a deck of cards? 4. There's one of each suit. How many total cards are there? 52. So, what's the probability of drawing a 4?
113.
112. 113. So you have 4 4s. You have 4 4s over 52 cards, which simplifies to 113. Oops, there's a line. So what's the probability of rolling a 6? 1 out of 6. We've done that a lot. So you multiply and you get 1 out of 78. So how many times would it take you to draw a 4 and roll a 6? 78 times. Okay, now we're going to talk about dependent events. Now, everything we've talked about up to now have been independent events, and that just means that the events, they didn't depend on each other. So whenever we rolled a 4, did that affect if our coin was going to land on tails? No, they didn't affect each other. But now we're going to look at examples that do affect each other. And the key term whenever you see a problem, if it says with replacement or without replacement, then that tells you it's going to be a dependent event. So here's the first example. So I have my deck of cards, and I want to find the probability of drawing a 4 and then drawing a 9 without replacement. So we need to find the probability of drawing a 4 first. So how many 4s do I have? 4. 4. Out of how many total cards? 52. And what is 4 over 52 reduced to? 113. So I'm going to draw my card, and I draw a 4. But do I replace it? No, because it says without replacement. How many cards do I have left if I took a 4 out? 51. Now I want to draw a 9. How many 9s do I have in my deck? 4. 4 out of how many cards do I have? 51, not 52. We didn't put the first 4 back. So we have 4 over 52 and 4 over 51. And what operation are we going to use? No. Multiplication. Because it says and. If it had said or, we would have added, but it says and, so we're going to multiply. And that multiplies to 16 over 2,652, which simplifies to 4 out of 663. So, to draw 4 and a 9 out of a deck of cards, it would take you 663 times, and you would only get that 4 different times. So are your odds pretty good? No, not at all. Now, I don't remember if you guys, I'm sure you've learned this, but I don't remember it. It's the fundamental counting principle. Raise your hand if you remember learning this. Nobody? At all? Okay. It's not hard at all. It just sounds kind of fancy. But, so this is what we do. We use to count our outcomes. So if you're flipping 2 pennies, what are your outcomes? Heads and tails. So you can get heads on one, tails on the other. What else could you get? Tails, tails, heads, heads, and then the opposite, tails, heads instead of heads, tails. So there are 4 different outcomes for flipping 2 coins. So the fundamental counting principle is just a different way. If you have a whole lot of things happening, it's a quick way to be able to see how many outcomes you're going to have without having to sit there and list them all. So first, we're going to do this example. So you're going shopping for a hat. You find a store that sells blue, white, and red hats. The sizes the store has available are medium and large. How many hat combinations are there? And this is kind of an easier example. You could just list them out, but we're going to try to do it without listing them out. So first we need our categories. What are our categories? Colors and size. So what different colors do we have? Does anybody remember?
Red, white,
Red, white, blue. So how many outcomes are there for colors? 3. There's 3 outcomes. Now what about size? Medium and large, so there's 2 outcomes for that. And for the fundamental accounting principle, yes, I heard you say it. What was it? 6. Multiply the 2 together. So that's easy, right? So let's list the combinations. There's a large blue, large white, large red, medium blue, medium white, medium red. And that makes 6. Okay. So let's pretend you're looking in your closet and you're trying to find something to wear and you're getting really frustrated because you can't find anything to wear. But let's say you have 15 different shirts in your closet, which you probably have more than 15, right? Yeah? But let's say you have 15. And let's say you have 6 different pairs of pants and 8 different pairs of shoes. And you're wanting to find out how many combinations you have for outfits. So, what are our 3 categories? Shirts, pants, and shoes. Yes, shirts, pants, and shoes. How many shirts are there? 15. 15. How many pants? 6. And how many shoes? 8. So what do we do with those 3 numbers? Multiply. So that means if you were looking at your closet, you would have 720 different outfits. Now they may not match, right? But I mean, you can't say that you don't have anything to wear because you would have 720 different combinations. So